In this video I'll show you how to use the E6B for simple division and multiplication. I would recommend using whole numbers for division and multiplication when using the E6B. It's not the most accurate tool when using non-whole numbers, so numbers with decimals and that type of thing. So if we look at the slide rule side of the E6B, the first thing we're going to practice is division. So the easiest way to remember how to divide with the E6B is to consider your division problem or quotient as a fraction. So if we think of a problem, let's say 10 divided by 2, if we were to make that into a fraction, then it would look something like this, with 10 as the numerator of the fraction and 2 as the denominator or bottom of the fraction. So if we remember that concept, this makes division really easy on the E6B flight computer. So to divide a number with the E6B, we're going to place the numerator, well, we're going to find the numerator on the A scale. And we're going to find the denominator on the B scale. So if you remember from the last video, the A scale is the fixed scale, the scale that does not move, the outer scale here. And then the B scale, sometimes referred to as the inner scale, is right there. So if we use our problem that we just came up with of 10 divided by 2, so with 10 divided by 2, 10 would be the numerator. So we would find 10 on the outer scale, and 2 would be the denominator, so we'd find that on the B scale. So our number 10 on the A scale, on the outer scale, is right here, and 2 on the B scale is hard to find. Well, we do have a number 20. Now, if we remember back to the concept of the floating decimal, remember that that decimal can be placed anywhere we feel is appropriate. So when we look at the number 20 here, that could represent 200, it could represent 2000, it could represent 0.2, and it could also represent 2, which is what we're using it for in this example. So now that we found both our numerator and denominator, we want to spin the B scale so that the denominator is underneath the numerator, like so. So now we have our numerator of 10 on top, or over, the denominator of 2. Remember, this 20, we're calling it 2 because we can place the decimal wherever it's appropriate to place. So this is 10 divided by 2. Now to find the answer, we're going to find what's called the 10 index on the B scale. So on the B scale, we're going to find the number 10, which is right here, and above the number 10 will be our answer. On the A scale, right here, 50. Now hopefully we know that 10 divided by 2 does not equal 50, but again, we have to understand the concept of the floating decimal. 10 divided by 2 equals 5. So instead of 50, we're calling this the number 5. Let's try another example. So in this example, we will say 12 divided by 3. So 12 would be our numerator, so that would be on the A scale, on the outer scale, and 3 would be our denominator on the B scale. So I found 12 on the A scale, and I have found 30 on the B scale, which I will use as a number 3. So I will spin the B scale so that the denominator is underneath the numerator of 12. So 12 divided by 3, if we find the 10 index on the B scale, we will find our answer of 4. Again, it's not 40. We have to use some logic to place that decimal. 12 divided by 3 equals 4. In the next example, we are going to divide 120 by 3. So 120 would be our numerator, and 3 would be our denominator. Now if you look at the A scale, you will not find a 120, but you will find a 12. Again, we place the decimal in its logical place. Okay, so now we are placing the decimal one digit behind where it normally is on this scale. So instead of the number 12, we're now calling this number 120. And we're dividing this number by 3, which we already have placed here based on our previous example. Again, this is not representing 30, this is now representing 3. So we have 120 divided by 3. If we look at the 10 index, the answer would be 40. Not 4, not 400, because neither of those would make sense. 120 divided by 3 equals 40. Now to do multiplication using the E6B, essentially we're going to do the same process that we just did, except backwards, because multiplication is just division backwards, and vice versa. So for multiplication, we're going to find one of the numbers that we're multiplying, find that on the A scale, and we'll place the 10 index underneath that number. And then we'll find the other number that we're multiplying on the B scale, and we'll find the answer on the A scale above that number. So for example, if we take 4 times 3, we could find the number 4 on the A scale, and we could find the number 3 on the B scale. So first let's say we're going to start with the number 4. So we don't have a number 4 on the A scale, but we do have a number 40. So we'll use that as our number 4. And we're going to place the 10 index underneath that number. So we've aligned one of the numbers with the 10 index on the B scale. So 4 is aligned with the 10 index on the B scale. The other number that we're multiplying is the number 3. So we're going to locate the number 3 on the B scale, and the answer to this product should be above that number on the A scale. So if we find the number 3, we don't see a number 3, but we see a number 30, which we will use as the number 3. We'll place our decimal appropriately. So we're going to call this number 3, and above that will be our answer of 12. 4 times 3 equals 12. In the next example, let's take 10 and multiply that by 5. So in this case, maybe I'll use the number 5 on the A scale instead. It doesn't really matter which number you place on the A scale and which you place on the B scale, as long as you align the 10 index on the B scale with one of those numbers. So let's find the 5 on the A scale. We don't have a 5, but we have a 50, so we'll use that as our number 5. And we will align the 10 index with that number. So let's move the 10 index here on the B scale to align with that number 5. Now we should locate the other number that we're multiplying on the B scale. So in this case it's 10. 5 times 10, or 10 times 5. We already have the 5 on the A scale, so we'll find the number 10 on the B scale. Well, it just happens to be in the same place we were, right? The 10 on the B scale is also the 10 index. Therefore, the answer will be right above 50. 5 times 10 equals 50. In the next example, let's take a bigger number. So let's say 100 times 18. So if we find the 100 on the A scale, and then we align that with the 10 index on the B scale, so something like this, right? We don't have a 100 on the A scale, but we have a number 10 on the A scale, which again, if we place the decimal where it should go, we can call that 100. So 100 is aligned with the 10 index on the B scale, the answer will be found on the A scale above the other number that we're multiplying on the B scale. So we're doing 100 times 18. So let's find 18 on the B scale. We happen to have 18 right here on the B scale. The number above that represents the answer, 18. Now we know that's not correct, right? 100 times 18 certainly doesn't equal 18. The answer 180 would also not really work because that would be times 10. 18 times 10 would be 180. So in this case, the answer here represents 1,800. So 100 times 18 equals 1,800 if we place the decimal in the correct spot. So I'd recommend practicing a few more problems by yourself using basic multiplication and division like we did here. This is a good way to get you confident with the concept of that floating decimal and placing it based on the best logical answer. Once you have that concept, then we can move on into calculating our time, speed, and distance in our fuel calculations for flight. If you don't understand that concept of the floating decimal, you will have a really difficult time with those calculations that we're going to do before our flight and during flight.